Hello everyone, welcome back to Electrosphere. In this video, we are continuing our Digital Multimeter Series. Today, I'll show you how to measure resistance correctly, why resistance reading can be wrong on a circuit board, the difference between copper and aluminum resistance, what contact resistance is, and how your own body can affect resistance measurement. Let's get started. Now, safety first. Before measuring resistance, make sure the circuit is completely powered off. Never measure resistance on a live circuit. Resistance mode uses internal DC from the multimeter. If external voltage is present, you can damage the multimeter if you are trying to measure resistance value. Let's get started. Now, to use this digital multimeter to measure resistance, first turn this dial to the resistance section. You will see the symbol ohm. You can see this ohm symbol here. So, this is our probe. You insert this plug probe into the COM and this red probe into the V ohm milliamp. Now, we are ready. I will start with measuring a resistor. Now, this is a resistor. You will take a resistor that is not connected to any circuit. Now, to measure resistance, you place one probe on one terminal like this, and you place the other probe on the second terminal. Now, like this. This is a wrong way to measure resistance value because the human body is also a resistor. If you want to measure the resistivity of a material or the resistance of a resistor, you need to put on something that can insulate you. Now, because the human body is a resistor, it can affect the reading value. So you need to put on something like this glove, although this type of glove. Now, I've put on the glove now. Now, this is a resistor. You place one probe on one terminal like this, then the other probe on the other terminal like this. You can see this is reading 0.97 kilo ohms. Now, ideally, it's best to first set this down to the lowest value, which is 200 here. If you are not sure of the resistance value of what you want to measure, just turn this down to the lowest value here, which is 200. So let me start with 200 with this same resistor. So I'll just pick it like this, and you can see. So if you see this symbol, it means the resistance value is higher than the range that you've set this down. So I'll switch it to the next available range for value, which is 2000 ohms. Now let me try it again. You can see this is reading 942 ohms. Now, when measure resistance, please, there's one thing you have to make sure that you place the probe on the terminal of the resistor properly, because there's one thing called contact resistance, and it can affect reading value. And contact resistance is caused by things like dust on the terminal of the test probe or other factors. Not placing the test probe on the terminal properly, it can also cause contact resistance, and this can also affect the reading value of the resistor. So just make sure you place it on it very well, and on the other one too, just like this. You can see this is reading 935 ohms. So the resistance value of this resistor is 942 ohms. So let me try another resistor. This is another resistor. Okay. Now I'll measure the resistance. Okay. So same way, just now there, and this is another resistor. So I'll first turn this down to the lowest value, which is 200. You can see this is 200. So now I'll place it here. You can see this is not reading anything, meaning the resistance value is higher than this 200. So I'll turn the dial to the next available value, which is 2000 ohms. So you can see this is not still reading anything. So let me turn it to the next available value, which is 20 kilo ohms. Now you can see this is reading 9.77 kilo ohms, which means this is 9,700 180 ohm, something like that. So the resistance value of this resistor is 9.78 kilo ohms. That's 9,780 ohms. You can see this is 20 kilo ohms. Now, take note of this. This is very important. If you measure a resistor while it's still connected on a circuit board, this is a circuit board. This is a circuit board. This is a resistor here. This is resistor. Now, if you measure a resistor while it's still connected to a circuit board, the reading may not be correct. Why? Because other components may be connected in parallel with the resistor. Now, this resistor on a circuit board, if you want to measure it, if you want to measure the resistance, you need to remove it to get the accurate value, because other components that are connected in parallel with this resistor will affect the resistance value of the resistor. So you'll not be able to get the exact resistance of this resistor. Also, although you can also use color code to calculate the resistance, So to get the exact value of this resistor, you have to lift one leg of the resistor, then measure again. This gives the true resistance. So if like this is a circuit board now and this is a resistor, and you want to get the resistance value, you just open one terminal here. Like, but I would have loved to demonstrate it here, but I know you understand what I'm talking about. Like this is the resistor. So you just open one terminal, like you remove it from this board. Then after that, then if the resistor is in isolation, you just pick your probe like this. Same way we did the first one, you just place it and just measure the resistance value. Now I want to use this digital multimeter to demonstrate copper and aluminum resistance. Now this is a copper wire, this is aluminum wire. We all know that the resistivity or resistance of aluminum is more than that of copper. So I want to confirm that using this digital multimeter now. Although you can see that the wire, they are of the same length. You can see that they are of the same length and almost of the same diameter. So I want to use this multimeter to confirm the resistance value of these two materials. Let me start with the copper. Now to start, as usual, you pick the multimeter, turn the dial to the lowest value, which is 200 here. Now I'll place this here and place this here. Now I can see that this copper wire, the resistance is around 38. No, wait, you can see it's around 24.6. But do you notice something that is dropping? Probably, maybe now you can see. Okay, it's 24.3 ohm. Okay, it's 22 now. Now you can see why we talk about something called contact resistance and not placing the test probe on the material firmly. You can see that the resistance value. Now I'll do something now. You can see this is the copper wire. I'll just slightly use these scissors to scrape the surface like this round, so that I can expose the terminal properly. Because of things like dust and oxidization, the other side, so I'll do it. You can also use petrol and methylated spirit to clean the terminal. So now I will measure the resistance value again. So now see, I'll place. You can see this is reading just 4.2 ohms. So which means the resistance value of this copper wire is 4.2 ohms or 4.1 ohms. Now let me do that for this aluminum wire. Now same way, I also scrape this terminal like this so I can expose it properly, so I can get the exact reading of the resistance value. Now just like this and like this. Now you can see for the aluminum it is reading 5.3 ohms. So you can see that the resistance value of aluminum is higher than that of copper. So you can see. This is what many beginners do not know. The human body is also a resistor. If you hold both ends of a resistor with your fingers while measuring, your body becomes part of the circuit. Especially when measuring high value resistor like 1 mega ohms or above, your body resistance can affect the reading. The value may drop or become unstable. So always hold the resistor by one side, or better still, you can put on something like this glove. Or another thing you can do concerning that is, normally, ideally, the terminal of this multimeter, is supposed to come have something like this. But I say I love to disconnect this because of something called contact resistance. Because from my experience, I don't like using this. Although you can only use this if you want to measure something on a printed circuit board that has smaller component of resistor. So you need to use this. But if I'm measuring something that has that surface area, like something like this, I prefer using the terminal like this. And I can clean this terminal regularly. Sometimes I'll even cut it with my scissors and open it and expose the terminal again to get accurate value. So common mistake to avoid, they include measuring resistance on a live circuit, not checking probe contact, measuring on board without isolating, touching both terminals with fingers, and ignoring material difference. Please avoid these mistakes and your reading will be accurate. Now you understand how to measure resistance properly, why board measurements can be wrong, what contact resistance means, why copper has lower resistance than aluminum, and how your body affects reading. In the next part of this video, we will go deeper into continuity testing and troubleshooting. If you learned something today, like the video, subscribe to Electrosphere and share it with someone learning electronics. See you in the next lesson.